Hello, folks. Welcome, 3.2. Very short one today. Should be hopefully. We're going to make a bar graph, a pie chart, and go over a segment of bar graph as well. It's going to be, yeah, so maybe it'll take a little longer than I expect, but we'll see. We'll see how long it goes. But we're going to start. We have some data here. We have 130 students asked about their movie preferences. We're going to make a bar graph and a pie chart based on that data. So we should kind of have a rough idea, I think, of how to do this from back, many courses ago, but let's go through. So bar graph's going to have an X and a Y axis. Now the X axis down here is going to be our movie preferences. So movie preferences, okay? And then the Y axis is going to be students. So students. All right, so we're going to go ahead and label the different movie preferences. We have comedy. We have, what are the other ones? Horror, drama, action, documentary. So horror, scary movies, drama, action. This isn't very easy sometimes. To write, it's kind of small here to make action. And last one being documentary. All right. So on the y-axis, we're going to have to, of course, number these. We go up as high as 46 in our data here, right? So I want to make sure that we go up to at least maybe 50 to kind of give us a nice little bit of room to fit all these numbers in. So if we're going to have to go up to 50, then I'm going to make it go by fives. We can choose kind of how to scale it. Let's scale by fives. So let's see here. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. It's not perfect. It'd be nice if we had actual graph paper for this. But, we have to make do with what we've got here. So 35, 40, 45, 50. All right, so of course, the bar graph is just going to make the bars as tall as they need to be to represent the number of individuals. So comedy had 32 individuals, 32 students. So that bar is going to go up to about 32. So here's, you can see where 30 and 35 is. So 32 is probably like right about here. So we'll make that bar go up to 32. Horror. So horror was 46. So we're going to have to make that bar go up, obviously. You can see where 45 is. 46 slightly higher than that. So 46 right about here. Action. No, and the drama's next. Drama was 15. So that one's only going to go up to 15. So that's right about this high. Action is 27. So you can see again where 25 is. So it's going to be slightly higher than 25. Again, this would be better if I had a grid to draw on, but for now we're going to have to eyeball it. So 27, roughly about here. And then lastly, documentary. So documentary had 10. So 10 is about this tall. All right, and there's your bar graph. So next we're going to move on to the pie chart. Now the pie chart, you can actually make it very precise. So what we're going to do to make the pie chart is we're going to find the relative frequencies of these. And we're actually going to calculate how big of an interior angle they would have here. So like how big the size of the slice should be. We can actually, instead of just eyeballing it, just guessing how big the slice is, we can actually very precisely calculate how big the slice is. Give me one sec. I think we'll get my paper with the data on it so I didn't have to recalculate everything. Just kind of copy it on. So let's go over the movies again. We had comedy. We have horror, drama, action, documentary. So we want to make a relative frequency. So these are the movie preferences, relative frequency. So to do that, of course, we're going to need its proportion. So remember, comedy was 32 out of 130. Remember, it said that there were 130 students. So 32 out of 130 comes to, let me put that in here, 32 out of 130 comes to 0.246. Horror was 46 out of 130, which proportionally is 0.354. Drama was 15 out of 130, which is 0.115, 0.115. What else? Action was 27 out of 130, which is proportionally 208, 0.208. And lastly, documentary was 10 out of 130, which is 0.077. All right, so these are the proportions, right? The relative frequencies for these. But now what we can do is we can actually calculate the size of the angle that their pi slice would have. So remember, a circle is 360 degrees, right? That's what a circle is, 360 degrees. So this essentially, remember, is about 24.6%. So what I would want to know is what's 24.6% of 360 degrees. And the way that we can do that is simply just by taking that proportion value, 0.246, and multiplying it by 360. Excuse me. So you take a calculator, you go 0.246 times 360, and it gets you 88.56 degrees. So that's how big that slice is going to be. So on here, put the center right there. 88.56, that's just under 90 degrees. Again, I don't have a protractor to make it perfect, but 88.56 is probably something close to that. So this is going to be my comedy slice. Horror, so let's calculate that one. It's 0.354 times 360, and that's going to be 127.44 degrees. So that one's going to be a bit on the larger side. Again, I don't have the tools to measure it perfectly. If I did, it'd be amazing. But I do have to kind of eyeball what I think 127 degrees is going to be, which is going to be roughly here-ish, I would say. So I would say this slice is about 127 degrees. It's not perfect, of course. I don't have a protractor, but seems pretty good. So that's horror. Drama was 0.115 times 360, which is 41.4 degrees. So that one is going to be around that big, I think. So this would be drama. Action 0.208 times 306, or I'm sorry, 360 is 74.88 degrees. So that one's pretty big as well. It's gonna be about that big. It should be a little bigger than that probably. We'll go there. I think I probably should make the drama one probably should have been a little bit bigger. Doesn't help when I tilt my head a lot. So there's your drama one. There you go. So that's going to be for action. And then the documentary is a small one. 0.077 times 360 is 27.72 degrees. So that's how big this last slice is. This should be about 27 degrees. That's for documentary. All right, so that's how you do it. Now, again, in a perfect world, what you would do is you would take a protractor, right, and measure these angles out. And you could get these pie slices to be absolutely perfect. Unfortunately, we don't have that right now, but like I said, so we kind of eyeballed it. But it's still important to know these because test questions will tend to ask for this information. Like, it might not ask you to make the pie chart, but you might get a test question that says, hey, here's all this information. How big is the central angle for comedy? They might just ask you that. And your answer would have to be 88.56. That's how big the central angle is for the comedy slice. So it won't ask you to draw it out, but it might ask you what that angle size is. And so therefore it's still important to know it. And it's not hard to calculate. Remember, all you got to do is take your relative frequency amount, just multiply it by 360. That's the key. If you do that, you've got your central angle. So no big deal. So a little bit of geometry coming into play here. All right, and then finally, the two-way frequency table down here. So we're going to input the data that's missing from this. Let's do it in purple, because purple is kind of a cool color. So notice the total column on the far right and the total row at the bottom. So to fill in these gaps, for females, for example, these 3 Democrat, Independent, and Republican numbers should add up to 1483. So if I take the difference between the total 1483 and the 574 and the 585, I get 324. So, and that should also add up to 780 with the Republican column total. So you take 324 and you add it with the 456, that should also add up to 780. So it should add up vertically as well. Same thing for the males here. If we take the difference and find that value for this gap should be 560. And then this one, we should add up total Democrats, and we have total Democrats at 1057. Again, this should work along the column as well. These 3 numbers added up should be 2,982. So you can also add these all up to check that as well. All right, but we have that now. Now what we're going to do, we're going to make a segmented bar graph, but before we do that, we're going to break everything down into its marginal distribution. Now, marginal distribution is essentially its proportions. So we're going to kind of create a new table, sort of. We'll have, same Democrat, Independent, Republican, and then females and males. But we're going to find if their proportion. So rather than 574 for the female Democrat, we're going to be doing 574 out of the 2982. So 574 divided by the 2982 is 0.192 roughly. So 0.192. So we're going to get its relative frequency in the slots here. So we're going to do that for each one. So independent female, that is 585 out of 2982. Which is 0.196. 324 out of 2982 is 0.108. And for male, we had 483 out of 2982, which would be 0.162, 0.162. Keep it going. 560 out of 2982. That's going to be 0.188. And then finally 456 out of 2982, which is let me see. 15.3. So 153. So 0.153. All right. So now what we're going to do is we're going to make a marginal distribution segmented bar graph. A lot of words there, a lot of big words. So same thing, same type of bar graph as before. There's not a whole lot of room here, so work with me here. So we'll do females first, do males second. All right. And then we're going to have the proportion on this side, or put percent or proportion. Say percent. So we'll convert everything to a percentage. So let's go by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yeah, nothing gets up to 20%. These all get pretty close, like 19.6, 19.2. Those are almost 20%. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right. So we're going to do female Democrat first. Female Democrat was 0.192, so slightly under the 20. So we're going to make a bar for female going up to nearly 20. Not quite, but nearly. Then right next to it, alongside it, we're going to put female independent, which is 0.196. So that one's going to be just slightly larger. Yeah, so you can see that those bars are essentially side by side. And then last one, we're going to put the female Republican. Again, it's going to be right alongside. It's going to be 10.8. So just over 10, just under 11, about here-ish. That would be for the Republican. All right, so let's do it for male as well. So for male, we had 162 for male Democrat. So going up to 16.2, roughly about here. Again, it'd be nice if we had a nice grid to kind of work with. We don't, it's okay. For male independent, 188, so just under 19. Should be right about here-ish. Hard to really eyeball it. Again, this is why it's nice if we had like actual graph paper to work with. And then finally, male Republican. So male Republican, 153. So right between 14 and 16, right about here. All right. And so there is your segmented bar graph. So essentially you have two columns, two big bars, but each bar is kind of broken into 3 components. It's not beautiful, but it works, gets the job done. And that's going to be it. That's going to be all we have for 3.2, just making these charts and these graphs. So it's important. The main things to take away here are going to be creating a table like this, being able to make or at least know what they look like, the segmented bar graphs, regular bar graphs, and pie charts. And also don't forget about calculating relative frequency and central angle. So the calculation of relative frequency, central angle, and marginal distribution, those calculations are important. And then just being able to read and interpret the different graphs. So, all right, that's going to do it. I'll see you guys in the next one. Bye for now.